Okay guys, here's another video in the series on vectors. We're looking specifically at vector equation of a line. This is it, vector equation of a line. It's always r equals a plus tb. You'll see that r, a and b are all vectors, t is a scalar. Okay, r represents the position vector of a point r on the line with coordinates x, y. So that's any point on the line. A is a particular point on the line. Sometimes we call it the starting point, but it's just a position vector of a particular point on the line. B is a direction vector. More on this later. But basically, it's a vector parallel with the line. And T is called the parameter. We often use a T because sometimes thinking of vectors in terms of acceleration, velocity, that sort of stuff, T standing for time works really well. But it doesn't have to mean time, it could mean anything that's a scalar. Right, here's an example of a line. R equals a plus tb, well r is always xy, a is 2 minus 1, and b is 2, 5. So that means 2 minus 1 is a point of a line, and it's going in a direction parallel to vector 2, 5. Now, we can draw this using a table. We'll just, if we separate it into x and y components, then the x coordinate will always be 2 plus 2t, and the y coordinate will always be minus 1 plus 5t. If we choose some different values for t, we substitute them in, now we get a set of points. You can see there, here, that's negative 2, negative 11, that's 0, negative 6, that's 2, negative 1, that's 4, 4, that's 6, 9. Now if we join them dots, we get a straight line. Okay, t can be anything, not just whole numbers. So it's all the real numbers in there, so you get all the points in the line to form a line. Here's an example for you. Find the vector equation of a line going through points A and B. A is 3, 4, B is 5, 2. Right, so that's the equation we want, r equals a plus tb. A is the point on the line. Let's pick A, 3, 4. B is not point B, it's not the position vector. B is the direction vector, so it's the direction of A to B, from A to B. So that is B minus A, so that's 2, negative 2. So the equation is 3, 4, r equals 3, 4 plus t, 2 minus 2. Now, this is one of the many times in mathematics that there's not just one right answer. You could also write 5, 2, because that's a point on the line, and that's the same direction. We use a different parameter there. I don't really need to if we've got the same direction vector, but it just makes it a little bit easier. Also this one, we got the opposite direction vector, because a line doesn't have a direction, a vector has a direction, but the line is parallel to this vector as well as it is parallel to this vector. Here's another example. We've got our other point 3, 4, and if it's parallel to 2 minus 2, then it's parallel to 10 minus 10. Okay. Doesn't only work in 2 dimensions, works in 3 dimensions. This our 2 points. So r equals a plus tb. Let's make a equal to a. And again, b is ab. So there's our answer. It's squashed up there, but that's how you do it. I just think it's important at this point to recap what we already know. I think you already know very well that the equation on the line is y equals mx plus c. That's called the Cartesian equation, because you plot it on the xy plane. So the way we did that in the past, we worked out what m was, we substituted a point and m back in the equation and worked out what c was, and we wrote our equation. This time, with the vector equation, we get a point on the line, we get the direction vector, and then we write our equation. So it's actually quite a simple process. One thing I do want to point out here, the gradient, minus 2 over 6, sorry, and the direction vector, 6 minus 2, you can see the connection there. Alright, this is a vector, not a fraction, so don't think of it as a fraction, but thinking of this as rise over run, this is run, rise. Or this is the gradient is the change in y over the change in x. Direction vector is the change in x, the change in y. Now just to prove that these are the same line, let's pick a couple of points. When x equals 0, y equals 10 over 3. Well, let's use our vector equation to check this. When x equals 0, then 0 has to be minus 2 plus 6t. So t equals 1/3. Substituting that in the second equation, you get 4 plus 1/3 minus 2, times minus 2, and you get 10/3. So it's the same. Pick another example, another point. When x equals minus 2, y equals 4. Sub that in here. When x equals minus 2, t equals 0, so y equals 4. You could pick a few more points and check a few others for yourself if you really don't believe me. Trust me, it works. Okay. Here's some good questions. Find the vector equation of the perpendicular bisector of the points 6, 3, and 2, -5. Okay. Here's a diagram. The diagram didn't come with a question. I just drew it to make it easier for you. So there's AB. There's the midpoint. Perpendicular bisector, so it has to go through the midpoint, and that angle there has to be 90 degrees. Okay, vector equation, so that's R equals A plus TB. A is the point on the line. The only point on the line that we know is the midpoint. So we'll get that. There we go, that's the midpoint. So A is going to be 4, -1. The direction vector, we don't know yet, but the direction from A to B is 1, 2. So if this is 90 degrees to it, then the direction of the line, it's got to be 2, -1. Now you can think of that as what will give you a dot product that equals 0. If you want to make two vectors 90 degrees to each other, what will give you a dot product that equals to 0? You could also think of it in terms of gradients and negative reciprocal. Or you can also kind of just think about it. If this is going up 2 across 1, then this has to be going across 2 down 1. Okay, so anyway, that's our equation. R equals -4, 1, which is m, and t equals 8, -4. I don't know why I just didn't put in 2, -1. I think I was just trying to be a bit smart. But there you go. Another example now. Same idea. Perpendicular bisector. Same 2 points. Why don't you pause the video, try this yourself, and then you can check your answer. Okay, here's the answer. So that's our vector equation. Starting point will be 5 minus 2. Direction vector of AB is 4, 2, so 2, negative 4 will be our direction of the line, so there you go. That's one possible answer. Okay, further example, you got two lines, vector equations of two lines. Where do these two lines cross? Well, when we had Cartesian equations, we'd always put y equals to y. Now we can put r equals r. It's where they meet, xy has to be equal to xy. So we equate the two of them. Now we've got two unknowns here, t and k. But we've also got two equations if we just look at all the x values and all the y values. So if we look at the x values, we get that equation. If we look at them, and we can simplify it. If we look at the y values, we get that equation, and we can simplify it. Now we've got two simple equations with two unknowns. Okay, to solve this, I'm going to use elimination method, and I'm going to work out that t equals 3. Taking t equals 3, I can sub that into line 1 and get 7, 7 as the answer. Now if you wanted, you could solve for k and substitute that into line 2 and see if that's the same. It will be the same. You can check that for yourself. Alright, I hope that was useful and helpful, and good luck with these questions.